All right, so today's Tuesday, not Monday. Quiz is Thursday. Worksheets 8, 9, 10, and 11 are all due Thursday. That was up on the board last week, so hopefully some of you looked at them a little bit. But I'm actually going to do some of 11 because 11 says getting ready for the quiz. So I will do these today, but if you need to see more like these tomorrow, you just got to let me know. So this is worksheet 11. It starts out with a question about, does this appear to be an identity if you graph it? What does that mean? How would you know? Which of the following appears to form an identity with this when you test it graphically? Yeah, it should look the same, right? Would look the same. So I'm going to talk about how to put this disaster in. I'm going to go parenthesis 2 sine x and close your parentheses before you square it, plus cosine of 2x, close both parentheses, and then divided by, and how are we going to put cosecant in? Yes, 1 divided by sine x. All right, so that's a lot of parentheses. Let's try typing that in. What mode do we need to be in? Okay, I have no idea if I typed that correctly because I wasn't really checking. I should be in radians, and I'm just going to start with a zoom 7, which is a zoom trig. Now, when I did it the first time this morning, that's not what I got, but I think that's the right graph. Did someone else get that? Okay. I think I forgot the 2x or something when I did it this morning, and it was kind of goofy. Anybody not getting this? Okay. I'm going to go back and show you what I have typed in. You double checking? I have 2 sine x and then outside of parentheses squared plus cosine of 2x and then a couple closed parentheses divided by parenthesis 1 divided by sine x. Did you do 1 divided by sine? Okay. All right. So what are you? Sine curve? I think going for one and type sine x. If it has to do with that background you have on there, was it always there? But I just mean if it won't cut it off because I don't know. All right, see when I do zoom trig, I get this and you're getting something bigger. All right, so if I typed in a different one, sine x, and then I went to the left and did bold, it is going right over the top. We all good? So the answer is choice B. Okay. What about this one? How do we type this guy in? This is graphically to determine, so it's a yes or no question. Tan x divided by, oh, no, plus, I can read. it's not well, plus 1 divided by tan x. And then in y2, 1 divided by sine x times cosine x. Something like that, maybe? Yep. What? How do you do it? You arrow to the left. Let me finish typing this. Plus 1 divided by tan x. Go down and get rid of this one. If you, when you're on the equal sign or whatever, if you arrow over to the left and so this little line is blinking, the first time you hit enter, it'll make it bold. There's other choices. You can also do the little circle because it'll trace over it as it goes. So you could see if they're the same if it traces over the same graph. Is anybody getting something that looks like this? Okay, let's see if it goes. I use the little bouncy ball, so if you see it can go bouncing over this exact same path. So I'm going with these are equivalent, yes? All right. This is a proof. You can't just graph it on the calculator. What do you want to try? Okay, what do you want to try with the left side? Okay, 1 over sine. Now it has a 2x, but I think this is still a good start. Because cotangent would be, okay, so it's cosine of 2x over sine of 2x. Why does that seem like a good plan? Because what did it give us? Common denominator. So we have 1 plus cosine over sine. Now, we need some trades for double angle stuff. One of them only has 1. The denominator has only 1 trade. It has to be what? The numerator, on the other hand, cosine 2x has a couple different options. Anybody want to see which one they think and tell me why? Let's think about what we are trying to get to. We're trying to get to a cotangent, which might look like what right before that? Cosine over sine. So we want there to be a cosine in the numerator. So maybe the 2 cosine squared minus 1, because would that get rid of the 1 as well? Okay. I'm pretty sure you can do it with any of them. It's just going to take more trades. Okay. What happens now? Okay. The 1s have to go away before you can divide anything else out. Now it's all multiplication and we can divide out the 2's and the one of the cosines, and we're left with what? Cosine over sine, which is right there. Pretty sure it's cosine of 2x had 3 different trades on the blue sheet. Do you have your blue sheet out? It's the double angle ones on the left. And we picked 2 cosine squared of x minus 1 because then the plus 1 we had out front and the minus 1 at the back here canceled. And then because there was no more adding or subtracting, then we could start canceling things. Does that make sense? Cosine over sine, which became cotangent, which is equal to cotangent that was way up there on the right-hand side. Everybody okay? All right. What do you want to try for this proof? How about expanding it with our sine A plus B, our sine, what are they called? Sum formulas or sum relations? Okay. Okay, so what would that look like? Okay, so that's what I heard. I think that's right. Sine A plus B goes sine of A, which is x, times cosine of B, which is 2 pi, plus cosine of A, which is x, times sine of B, which is 2 pi. Okay, perfect. Now what? Yes, let's go to our unit circle and put some values in. Sine of x is going to stay sine of x, but cosine of 2 pi is 1. Cosine of x is going to stay, but sine of 2 pi is 0. So this goes away, and we just get sine x equals sine x. Make sure you show stuff, though. I mean, this isn't much to show, right? Just it's a verify or proof, so you need to not just like cross all this out and go, yeah, it's sine. Okay, kind of show that this was 0, so I can follow clearly what you did. Does that make sense? All right. Not a hard proof at all. All right. This is tricky. All right. Let's not even read the rest of the question yet. Let's just look at this part. This is cosine of something plus something. Can you expand that? So this is a sum relation, and it goes cosine, cosine minus sine, sine. All right. This is not something you can do on the calculator. This is going to be a messy radical answer. All right. We can substitute cosine pi over 4, sine pi over 4 from our unit circle, right? But cosine of x and sine of x come from this happy little bubble over here. Okay? What quadrant are we talking about? Second quadrant. Wow, that was a straight line. Wow. Some serious issues today. All right, cosine would be -2 over 5. Yes? Did I do that right? Adjacent over hypotenuse, or x over r? Okay. Very carefully, how are we going to find that value? (25 minus 4 is 21. Square root of 21, is it positive or negative? Positive. Okay. You want to put values in now? Everybody all right? Square root of 21? Okay. Cosine of pi over 4 is? Okay. Cosine of x? No, -2/5, right there. They gave that one, right? Okay. Minus sine of pi over 4, also square root of 2 over 2. Sine of x, uh-oh. Yes, the sine over here of this is square root of 21 over 5. Everybody okay? Now, I know you want to cry a little bit, but we're just going to multiply these together and write -2 square roots of 2 on the top and 10 on the bottom. We're going to multiply these together. That's supposed to say 21. It's kind of messy. That becomes square root of 42 over 10. Now, what could we reduce if we wanted? This one could become negative square root of 2 over 5. Does this simplify 42? What goes into 42, guys? It's 2 times 3 times 7, right? Are the primes that go in there? Is that any of those perfects? Yeah, no. So you can leave, oh, I don't know where that came from. You can leave it messy like that, or you could leave it messy like this. There's no nice way to write this. You could leave it all because it had a common denominator of 10, or if you wanted to reduce the first piece, you'd have to leave 2 separate fractions. It's your favorite number right there? Okay. All right. Remind me tomorrow if you want me to do another one like this, we can, all right? Let's keep moving for today. All right. This one says hint graph because it's kind of messy to do a bunch of trades. So let's just try graphing it. How do you want to do it? Y1 and Y2? Okay, so in one, we're going to put the tangent of x close parentheses squared. And in the other one, we're going to put negative square root of 2, arrow to the right, divided by 2. Yeah, that's not what that says. Try again. Okay. Oh, I'll get it right eventually. Then how do we do secant? So 1 divided by cosine. All right. Now, a couple things are going on. I'm getting some intersection points, but did this have something in the directions? I did say 0 to 2 pi. So I'm going to go change my window for x to 0 to 2 pi exactly, so that I know I only really care about the intersection points that are in this window. All right, it's multiple choice, and they want exact answers, so let's just try some of the choices. If I just do trace pi over 3, maybe? If I do trace pi divided by 3, does that go to an intersection point? No. What do you want to try? 3 pi over 4? 5 pi over 4? Did it jump to those 2 intersection points? So choice A seems okay? Everybody all right? All right. You could do this one by graphing as well. I'm going to do trades because I think it's good practice. What is a secant squared, guys? What's the Pythagorean identity for that one? So 1 plus tangent squared is a secant squared. Then it had a tangent and a 1. Okay. So what do you want to do now? Subtract a 1 from each side. So now we could take out a tangent, Miranda said. So we'd have a tangent times a tangent, x plus equals 0. So either tangent is 0 or tangent of x is -1. Okay, so anything that has a y back here will have a tangent of 0. So that's true at 0 and pi, is that right? And we're looking for ordered pair maybe like this. And it could be switched with the negatives, right? 3 pi over 4 and 7 pi over 4. So choice B seems good. This line right here wasn't really part of the solution. It was just what we were looking for on the unit circle, right? All right. Multiple choice. Which of these could be in a proof of this? Okay. I don't ask a question like this on the quiz, I'll be honest. But if you started here, what might you do next? Okay, sine x over cosine x plus 1 over cosine, which has a common denominator, so you would get, which is choice. Okay, not one like that on the quiz, guys. If you had to finish that proof, it gets messy. You have to multiply top and bottom by like 1 minus sine or something. We're just not going to go there. Oh, it's not that bad. It's just a proof. But yeah, we could finish it. I don't know which trades, how much trading you have to do. Calculus. This one says how many numbers between 0 and 2 pi satisfy this? Why don't you guys graph it on your calculator? I'm going to actually graph it by hand because I should be able to do this. The sine of 2x should just finish 2 periods. And the cosine by 2 pi I'm thinking 1, 2, 3, 4 intersection points. Is it better on your calculator, but still 4? All right, these are definitely on the quiz. Before we do this section though, and before you're working ahead, I think on the quiz it would just have a 2 here. I can talk in a minute if you want me to about what you would do with that 16, but just change that to a 2 so it's more like a quiz question would be. Did I just say 18? 16, whatever it said there. Okay. All right. So can you find something on your blue sheet that says sine, cosine, minus cosine, sine? Okay, and what are the A and B for us? 42 minus 17, which is 25 degrees. That one wasn't too bad. This one is tricky. Says sine, cosine plus sine, cosine, but look at the values. If this is A and this is B, this is B and this is A, so we could, it's multiply, right? So we could flip this around to cosine pi over 5 times sine of pi over 2, and it would mean the same thing. We just switch the order. So then it says sine, cosine plus cosine, sine. Does that Sound more like the one on there? Okay, and it really didn't matter because it was adding anyway. So we're adding a pi over 5 plus a pi over 2. Can you give me an exact answer in radians? 1/5 plus 1/2. Okay, I got a common denominator, but you can do it on your calculator. I'm agreeing with Basma, sine of 7 pi over 10. Everybody okay? It's supposed to say. It's probably only 1 point. It would probably be wrong. So make sure yeah. All right, what about this one, guys? 2 sine 3x cosine 3x. You find it? 2 times sine times cosine is the sine of the double angle. But ours is not just an x, it's a what? 3x, so we would write sine of 6x. Now, it originally said what, 16? So it originally said this. If I put that on the quiz, which I won't, you would have to separate it like 8 times this. And so you'd end up with 8 and then sine of 6x. But it's not on the quiz that way. All right, last one. Do you have one that goes cosine, cosine minus sine, sine? What is it? So if we put in a 7y and a 3y, we'd just have a cosine of. Okay, those are pretty easy on the quiz. Till I take your blue sheet away, which I won't do. I quickly said I wasn't going to. Of course, she dropped out of her chair. All right. This section is just a pain in the neck, but we can do these. It's just substituting in, guys. It's just that we have a sine of A that's in quadrant 2. So I'm going to go over here. I'm going to draw a quadrant 2 angle. A is actually the value that takes it all the way over to here, but opposite over hypotenuse, what would be this little missing piece down here? Okay, because we could do Pythagorean theorem, but we're pretty smart. So the sine they already told us was 4/5. What would the cosine be? Okay, we're going to need that for a bunch of substituting in a minute. And we're going to need B for some of these problems. So I'm going to do B at the same time. B is in quadrant 1. And just to confuse us, this time opposite over hypotenuse is the 3/5. So this side is 4. And this is B in here. So the sine of B is 3/5. And the cosine of B is 4/5. So out of all those, this was the only one that was negative, right? Was cosine of A. All right, I'm going to take a picture of this because we're going to need it on the next 3 slides. Whoa, just kidding. I'm going to put a giant circle. All right. So for this question, sine of 2A, actually all we need is A, right? The formula is 2 times the sine of A, sine of B. And you plug those values in, you'd have 2 times what? Oh, sine A. Oh my goodness, what did I just do? Me too. I'm like what? Oh my goodness. I told you I was sleepy when we started. 2 sine cosine. Okay, So putting the values in, we have 2 times what? Okay, so we had, this one was -3/5, and that one was 4/5. So we get -24/25. That's it. All right, I'll try to be a little more coherent on this one. Cosine of 2b. It switched to cosine, but it also switched to triangle B. Cosine 2b is a double angle with 3 trades. What do you want to trade for? You pick. Is the first one sine squared minus cosine squared or cosine squared minus sine? Okay, cosine squared minus sine squared. Okay. So the cosine is negative, oh, we're doing B. Cosine is positive 4/5, right? Because we're doing B. 4/5 squared minus the sine, which is 3/5 squared, would be 16/25 minus 9/25, or okay? All right. You guys try the next one. No? Next one's icky? All right. We'll do the next one together. What's going on this next one? It's a half angle, so it's a plus or minus square root of, you absolutely can, but we need to talk about why for the rest of us. All right, guys. Remember, to decide if it's plus or minus, you have to look at where the angle is when you divide it by 2. Angle A was in quadrant 2, somewhere between 90 and 180, and I'm just talking degrees because that's what we think in, right? This angle A, they told us, was in quadrant 2, so it's somewhere between 90 and 180. But we want the sine of A divided by 2. When you divide those by 2, you get between 45 and 90, which would be quadrant 1. In quadrant 1, do we have a plus or a minus for the sine? Plus. So we get to throw this away, and it's just going to be positive from here on out. All right, so it is the square root of 1 minus, we're using A, so what was the cosine of A? -3/5, all divided by 2. Okay, don't put the square root in your calculator, but go ahead and type 1 minus -3 divided by 5. Enter, and then divided by 2, math, enter, enter. Or you could put parentheses around the top, divide by 2, and then do math, enter, enter. Or you could just use a common denominator. Yeah, I got 8/5 divided by 2 is 8/10 or 4/5, but it was under the radical, right? Okay, square root of 5 is, or square root of 4 is 2. This was all under the radical. 2 over the square root of 5, which becomes 2 square roots of 5 over 5. All right. All right, that's that one. This one, I think you'll like a little bit better, maybe, because we've done a couple of these already today. Can you expand this out? All right, so plug some values in. So I have 16/25 minus a negative or plus a positive 9/25. Yep. Anybody? Does that make sense to anybody how that could be 1? These are complementary angle. Well, this little angle in here, do you see how the 3 and the 5 switch? So those angles are complementary. So the difference between them is 90. And at 90, the difference between them is 90. So the sign at 90 is 1. Okay. So something similar is going to happen kind of here. How would this go? Cosine. Oh, yeah. They switch the letters around, which actually it doesn't matter at all because what's cosine is what kind of a function? Even. So it wouldn't matter at all. You can switch the letters when you expand it, but you don't have to because look, it's all multiplication. It's all multiplication and addition, which can be done any order, right? All right, I do have to put my little picture back on here. So what are the values we're putting in this time? Remember a minute ago we said the difference was 90? What's the cosine at 90? Is that the last one on that worksheet? Okay, quickly flip to worksheet 8. Oh, I would like to think, but that didn't work out so well for me last week when I said 100% participation. Still got people who didn't turn anything in. Not necessarily in this class. All right, this is worksheet 8. Couple examples. The directions here say between 0 and 2 pi, find exact values. So I don't know what that thing is. I'm just going to use a theta. Cosine of theta, if I divide by 2, is 1/2. I whip out my handy dandy unit circle. And between 0 and 2 pi, the cosine is 1/2 at pi over 3 and 5 pi over 3. All right, the next example looks a little more confusing to me because I can't find cotangent on my unit circle. It is 1 over tangent, or cotangent is x over y, right? So you really could put it on your unit circle. You could also just flip it over. When you flip both sides over, you get the tangent is what? So I'm looking for something that has a square root of 3 and a 1 like that. So pi over 3, but this time be careful. We need another positive place. Tangent needs to be positive. Anything else in that little section look confusing? Those are pretty straightforward. I think the next section down a little ways, does it say this? All solutions? All solutions mean you got to put plus or minus on, right? It says radians, and some of them apparently nearest thousandth means some of them aren't going to come out nice. Let's try this first example. Can you solve that for me? Say sine of x equals what? 3/4. Is that on my unit circle? Okay, so instead I'm going to go to my graphing calculator and I'm just going to graph the sine function and the line 3/4. And I am going to make my window 0 to 2 pi, if it isn't already, because that's what it said in the directions, right? No, it says all solutions. Just kidding. All right, I'm going to do a zoom trig then, just because I want you to see that it does repeat. All right. Yeah, because I'll probably do the rest of the examples tomorrow. Here it's repeating, yes? It's a sine function, so how often is it going to repeat? Every 2 pi, okay? So how are we going to find the two values that we want? The two intersection points, exactly. Jared. So we're going to go second, trace, intersect, enter, enter, enter. I get 0.848 for the first one. And then if I go second, trace, intersect, enter, enter, but then I got to scroll over closer to the other one. I get 2.294 maybe. And those will repeat every 2 pi. Does that seem okay? Can do that section where you just graph. Now, I will tell you, there's a bunch of questions like this on this worksheet. 4 cosines minus 3 cosines is a cosine of x. I get cosine of x equals 5, which happens where? Not possible, no solution. Nice try, Hofbauer, right? There are several no solutions on this worksheet, okay? If I go, I don't know, where do you want to go next? All solutions in radians? That looks like a no solution, number 7 to me. 3 halves, that's a no solution, right? Somebody pick one that looks like it might be a factoring question. Oh, these are already factored. Let's do this one super fast. This first one is factored. So tell me all the solutions from 0 to 2 pi. Where's the sign 1 or 1/2? Anybody agree or disagree? Okay. This one is factoring. How will this factor? The 2 has to be negative and this one positive. Does that seem okay? So we get the sine of x is either positive 1 or negative 1/2 this time. So I think pi over 2 is still a solution, but this time instead of pi over 6 and 5 pi over 6, we have 7 pi over 6 and 11 pi over 6. Is that right? Okay. Can I factor one more? Am I speedy? What do you want to try? 13? We can take out a tangent of y. So we get, where is the tangent equal to 0? Or the sine equal to negative square root of 3 divided by negative 2 would be positive square root of 3 over 2. So the tangent is 0 where? And the sine is square root of 3 over 2 at this had a square bracket to my mind, so I put 0, pi, and 2 pi. Did I get that right? All right. So tomorrow, more questions.